Hello everyone, you are on the channel Who Created It and How. Today, we're journeying back in time to an era without cranes, without power drills, without any of the heavy machinery we take for granted. We're going to explore the mind-boggling question: how did ancient civilizations build their colossal monuments? From the pyramids of Giza to the temples of Stonehenge, these structures weren't just built. They were engineered with a level of precision that continues to baffle us today. So grab your virtual hard hat and let's dig into the secrets of ancient construction. Let's start with the most iconic of all, the Great Pyramid of Giza in Egypt. This behemoth is made of roughly 2.3 million stone blocks, with some weighing as much as 80 tons. That's like lifting 10 elephants at once. So how did they do it? The prevailing theory involves a combination of sheer manpower and brilliant engineering. First, quarrying the stone. The Egyptians used copper chisels and dolerite pounders to carve out massive limestone and granite blocks directly from the bedrock. They would cut deep grooves, then likely insert wooden wedges. By soaking these wedges with water, the wood would expand, creating immense pressure that would crack the stone along the desired lines. It was slow, painstaking work, but incredibly effective. Now, how do you move an 80-ton block from the quarry to the construction site, sometimes hundreds of miles away? Archaeologists believe they used massive wooden sleds. A fascinating wall painting discovered in the tomb of Jehutihotep depicts 172 men pulling a colossal statue on a sled. But here's the clever part. You can see one person pouring water onto the sand in front of the sled. Recent experiments have confirmed that wetting the sand just right reduces friction by about half, making the task significantly easier. It's a simple solution, but a game changer. These sleds would have been pulled along specially prepared causeways, sometimes transported down the Nile River on massive barges during the annual flood season, which brought the water level closer to the Giza Plateau. Okay, so the blocks are on site. The next challenge is lifting them into place, hundreds of feet in the air. This is where the debate really heats up. The most widely accepted theory is the use of ramps. But what kind of ramp? A long, straight ramp would have been impossibly huge, requiring more material than the pyramid itself. So experts propose alternatives. One idea is a spiral ramp that corkscrewed around the outside of the pyramid as it was being built. Another suggests an internal ramp system, a series of tunnels winding their way up inside the structure. Recent thermal imaging scans of the Great Pyramid have revealed some mysterious anomalies, spiral-shaped voids which lend some credibility to this internal ramp theory. Whatever the method, it would have involved thousands of workers pulling and pushing these giant blocks up the slope using ropes and levers. Let's shift our focus to Europe and the enigmatic stone circle of Stonehenge. Built in several phases between 3000 and 1500 BC, its largest stones, the sarcens, weigh up to 30 tons. These were transported from about 20 miles away. Like the Egyptians, the builders likely used wooden sleds and rollers over a prepared trackway. Imagine hundreds of people working in unison, slowly rolling these monoliths across the rolling hills of Wiltshire. The smaller blue stones are even more mysterious. They weigh about 4 tons each, and their geological origin is the Preseli Hills in Wales, a staggering 150 miles away. How on earth did they transport them? It's possible they were moved part of the way by water, floated on rafts along the coast and up rivers before being dragged the final stretch overland. It was a monumental logistical feat, requiring incredible planning and social organization. Once at the site, the stones had to be erected. Archaeologists believe a large pit was dug for the base of each stone, with one side sloped. The stone would be dragged until its base slid into the pit. Then, using a complex system of wooden A-frames, levers, and sheer muscle power from hundreds of people pulling on ropes, the stone was slowly heaved into a vertical position. To secure them, the pits were packed tightly with rubble. And what about the lintels? The horizontal stones that sit on top, they were likely raised using timber platforms, built up incrementally like scaffolding, or perhaps by building a massive earth ramp to drag the lintel up and into place. The precision is astonishing. They used mortise and tenon joints, a technique from woodworking, to lock the lintels securely to the upright stones. This shows they weren't just piling rocks, they were master craftspeople. Now let's travel to the Americas, to the breathtaking Inca city of Machu Picchu, perched high in the Andes Mountains. What's incredible here is the stonework. The Incas were masters of a technique called ashlar masonry, where stones are cut so precisely that they fit together without any mortar. You can't even slip a piece of paper between them. And these aren't simple cubes. They are complex polygonal shapes that interlock like a giant jigsaw puzzle. This made their buildings incredibly resistant to earthquakes, which are common in the region. How did they achieve this perfection? They used stone and bronze tools to painstakingly pound and grind the surfaces of the rocks. They would place a new block on top of a finished one, scribe the contour of the lower block onto the upper one, then remove it and carefully chip away until it was a perfect fit. It was a process of trial and error, repeated over and over, requiring immense patience and skill. The stones themselves were likely moved using ramps and levers, with thousands of workers maneuvering them into their final positions on the steep mountain slopes. Let's cross the Pacific to Easter Island, or Rapa Nui, home of the famous Moai statues. These giant stone heads, some weighing over 80 tons, were carved from volcanic tuff at a single quarry. Over 900 statues were made, and hundreds were successfully transported to stone platforms all around the island's coast. The mystery has always been, how did they move them? For a long time the theory was that they were laid on their backs on wooden sleds, but the island's resources were limited, and this would have required a huge amount of wood. More recent experiments, inspired by oral traditions of the Rapa Nui people, suggest a more radical idea. The statues walked. By tying ropes around the head of a statue and using teams of people to rock it from side to side, it's possible to shuffle it forward in an upright position. Imagine a giant refrigerator being wiggled across a kitchen floor. It's a slow and risky process, but experiments have shown it's feasible. This would explain why many abandoned statues are found along ancient roads, fallen forward or backward. What unites all of these incredible achievements? It's not alien technology or lost magic. It's human ingenuity, immense social organization, and a deep generational understanding of physics and materials. These projects took decades, even centuries to complete. They required a shared vision and a level of cooperation that is hard to fathom today. The workforce wasn't just mindless labor, it included skilled engineers, planners, tool makers, and craftspeople. They used simple machines like the lever, the inclined plane, and the roller with astounding effectiveness. They understood friction, leverage, and center of gravity. These monuments are a testament not just to brute force, but to brilliant minds and a united community. They remind us of what humans are capable of when we work together towards a common goal. So, the next time you see a picture of the pyramids or Stonehenge, don't just see a pile of old stones. See a masterpiece of engineering, a story of human determination, and a puzzle that we are still working to solve. These ancient builders may not have had our machines, but they had something just as powerful: knowledge, patience, and the will to create something that would last for millennia. Thanks so much for joining us on this journey into the past. What ancient marvel do you find most impressive? Let us know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you don't miss our next exploration. See you next time on Who Created It and How.